Video, and today we have a 2661 first completely painted row or column. This is a pretty straightforward problem. It says giving a zero indexed array of an m times n integer matrix. Array matrix both contain all the integers in the range 1 to m times n. So basically array has all the numbers that are in here, right? It's just this is a 1D and this is a 2D. And then it says go through each index in array starting index 0 and paint the cell. So it's a simulation. Paint the cell containing the integer array of I. So you go through these and then you find, so this is 1, right? You look for the 1 here, which is this one, and you paint it. And then it says return the smallest integer I at which either a row or column will be completely painted in matte. So basically you keep going until you paint either a row or a column, and that index you return. Simple as that. So basically this question, when you think of two things, right? The question is, how do we detect if a row or a column has been fully painted, and how do we even run the simulation to begin with, right? So running the simulation basically is pretty straightforward. All you need to do is in the 2D matrix, just map the indexes to the actual values. And that's what I did here. So basically I started by defining the row length and the column length. And then after that, I started having this hash map, which is map to index. Basically what it does is I go through the 2D array, and then I add the value as a key and the indexes as a value. And we're going to need this later on, right? Now, all we do is to run the simulation. We just simply run the simulation, right? And then in order to detect if there is a complete row or a complete column, we can basically keep count of every row column in the whole matrix. And once a row reaches the length of the columns, because like, let's say this 1 and 4 row right here, right? The length of that row is going to be equal to column, which is this one, because basically we count the columns, right? And then if we reach a column where the length of it is equal to row, that also counts, right? So we keep the track of that, right? Basically, so we have this RC counter, and then we're just going to run the simulation, right? Basically, I extract the indexes from the map. Once I get the indexes, I'm going to increment for both the row and the column, right? And then I just added this R and C so they don't clash with each other as numbers. And then what I do is I just check if the row reached column length or if the column reached row length, just return the current index we're on, right? Straightforward. And then this submits, as you can see, and it works. And the time complexity of this is O of n times n, actually, for this part, and O of n for this part, which is the length of the array. This is m times, this is the matrix. And the space complexity is it's the same. It's literally the same. It's the same, yeah. So yeah, that's been it, guys. Thank you guys for watching. See you in the next one.